Okay, so now we are now starting example 5, which is very similar to example 4. We just now have this square to deal with, which this means that this function is going to be a quadratic. A quadratic is something that is squared. Alright, so first up, we're focusing on the function. We're going to get a graph by picking 5 points, finding our domain and range. Then we're shifting gears to the inverse. We're going to find our equation, get those points on our table, plot those bad boys, and find the domain and range. And also, we're going to be graphing the line y equals x to make sure that our graph is going to be symmetrical to that line. So moving back up to the top, let's begin by focusing on our original function. So, remember when we make our table, I typically pick the same 5 points every time I do this. I like to pick a little negative, a little positive, and 0. And I like to keep my numbers small. So I'm going to pick -2, -1, 0, 1, and 2. Okay, so let's figure out, we have our x's, we got to find our y's so we can plot them. So my first one, we're going to be solving for f of -2. So I'm going to replace my x with the -2. So that x right there is going to change into a -2 raised to the second power minus 4. Okay? So -2 squared, -2 times -2 is 4. And 4 minus 4 will give me a 0. So the first point we'll be plotting is -2, 0. Alright, we do the same thing with the next point. So now we'll be solving for f of -1, so that x right there is going to transform into a -1. So we have -1 squared minus 4. -1 squared is -1 times -1, which is just a 1. And 1 minus 4 gives me a -3. So the next point I'm going to plot is that -1, -3. Alright, let's move it on to 0. F of 0. So 0 raised to the second power, we're going to substitute 0 in for x. Then minus 4. Alright, so 0 squared is going to be 0. And 0 minus 4 is -4. So my next point I'm going to plot is that 0, -4. My next point, f of 1. So I'm going to replace my x with a 1. 1 squared minus 4. 1 to the second power, 1 times 1 is 1. Minus 4 will give me a -3. So the next point I'm going to plot is that 1, -3. And my final point I'll be plotting is that f of 2. So I'm going to replace x with a 2. So 2 raised to the second power minus 4. 2 times 2 will give me a 4, and 4 minus a 4 will give me a 0. So the last point I'm plotting is that 2, 0. Alright, so since this is a quadratic, I wonder if you know what the graph shape should kind of look like when you graph a quadratic. Well, if you thought it was parabola, you are correct. So our graph should be a parabola, which a parabola is kind of like a U-shaped graph. So our graph should be a U-shaped graph when we get done. So let's see what happens when we get these points plotted. So my first point is at -2, 0. Bam! My next point is at -1, -3. Bam! My next point is at 0, -4. Bam! My next point is at 1, -3. Bam! And my last point is at 2, 0. Holy hot dog, you guys, I'm seeing that U shape. Look at that. There it is. Lovely. Alright, so this is our original function graphed. Okay, so now we're going to move on to the domain and the range. So domain, remember, those are the x values. So you ask yourself, how far left does it go? How far right does it go? So how far left is it going to go? Now, even though it doesn't look like, our graph will keep heading to the left for forever. This will gradually get wider and wider, even though it doesn't look like it. So my domain is going from -infinity. Alright, and then when we ask ourselves, how far right does the graph go? Okay, again, since the graph gets wider and wider, it will head in the positive infinity direction for forever. So your domain is going to be at positive infinity. Alright, which if you like inequality notation, since we're going from all the way negative to all the way positive, we have found all the numbers. So this will be x is all real. Alright guys, so for the range, this involves the y-axis, so you ask yourselves, how low does it go? Well, it only goes down to there. Okay, that's as low as that graph will go. Okay, so the lowest y value on my graph is at -4, and it can equal -4, so we're going to put a bracket on that bad boy. And then you ask yourselves, how high does the graph go? Alright, well those arrows mean it heads upward for forever, so to infinity and beyond with Buzz Lightyear. Holy hot dog. So my range is from -4 to infinity. And if you like inequality notation, here our range involves y's, and we have something involving a -4 in there. So you ask yourselves, are these values larger or smaller than -4? Well, the values up here are definitely larger than -4, and we can equal -4. So this will be greater than or equal to -4. Okay, so that would be the domain and range of the original graph. Awesome. Okay guys, so now we're going to shift gears to the inverse. So first up with the inverse is to find the equation of the inverse. Okay, so we start with our original function, which is f of x equals x squared minus 4. Okay, remember when we solve for the inverse equation, it's helpful to change f of x to a y so we can interchange the x and the y real easily. Okay, let's get going, you guys. So first up, we're going to be interchanging the x and the y values. So my y is going to transform into an x, and my x is going to transform into a y. Okay, so we're going to start with our x, since my y is transforming into an x, equals, okay, my x right there is going to transform into a y, and everything else stays the same. So the squared and the -4 stay there. Alright, from here we solve for y. Again, I personally like my y to go first, so I'm just going to flip my equation around. So y squared minus 4 equals x. Alright guys, let's get x on one side by itself. I'm excited. So first step, to move -4 to the other side. The opposite of -4 is +4, which -4 plus 4 is 0, so they cancel out. And then when I add 4 on the other side, these are not like terms, so I cannot combine them. So my next phase of the equation will be y squared equals x plus 4. Okay guys, we're so close to getting y by itself, but currently that squared is getting in the way. Ah, silly squared. So the way that we undo a square, if you remember from the previous example, so in example 3 I think it was, that had the squared, the way that you undo a square is to square root that thing. You have square root it on both sides, like that. Okay, so the square root will cancel out the squared, so you're just left with y on this side, equals now, don't forget from that example 3 video, whenever you square root both sides of an equation, remember a plus or minus must pop up, always. So this will be plus or minus the square root of x plus 4. So that is our inverse equation, but we like to use the fancy notation. So my final answer, I'm going to use the fancy notation. The inverse of f of x equals plus or minus the square root of x plus the 4. So that is our inverse equation. Wasn't that a blast, you guys? Now, after we find the equation, we're going to be graphing the inverse function and then finding the domain and the range. So if you remember from the previous video, okay, since we already have a set of points in our original function, to get the new set of points, remember, all we have to do is interchange our x and our y values. We don't have to go through this long process of solving like we did up here. So we're going to be using these points, and all we're going to do is interchange or flip-flop our x's and our y's. So the first point we're going to be plotting, the -2, 0, is going to transform into a 0, -2. Okay, and then -1, -3 is going to transform into a -3, -1. Okay, my 0, -4 will change into a -4, 0. My 1, -3 will change into a -3, 1. And finally, my 2, 0 is going to change into a 0, 2. Alright, so let's get these points plotted. And technically, before we even graph it, well, we'll talk about domain and range in just a second. So let's get these points plotted. So my first point is at 0, -2. So 0, -2, right there. My next point is at -3, -1. So -3, -1. Right here. Alright, my next point is going to be at -4, 0. So 1, 2, 3, 4. There we go. Alright, my next point is at -3, 1. Oh, hold on. -3. Yes, that's right. Sorry, guys. Alright, my next point is at -3, 1. I'm sorry, this point is wrong. Sorry, guys. Jeez, Miss Sloan, get it together. This point was supposed to be here. -3, -1. My bad. Alright, and then my next point is going to be at 0, 2. So 0, 2. Alright, so I've just plotted these points. I apologize, I plotted one in the wrong spot, but now it's in the correct spot. Alright, and so my new graph, this one's going to look like a sideways view. It's going to be pretty cool. Look at this thing. Whoa. Holy hot dog, you guys. That's pretty cool. Okay, so that is my inverse function graphed. And now the domain and range. Without even having to sit here and ask yourself how far left, right, up, and down it goes, remember, the domain and range interchange between the original function and the new function. So let's see what magical things will happen. So my domain of the inverse will be the range of the original. So my range of the original was -4, infinity. So that will be my domain of the inverse, -4 to infinity. And if you notice on the graph does go, the lowest x it goes is -4, and it extends in the positive direction for forever. So that is the correct domain. And in inequality notation, the range was y is greater than or equal to -4, but now since we're dealing with domain, that y will just turn into an x. So x is greater than or equal to -4. Alright, and then the range, since the domain was from -infinity to positive infinity, that will be my new range. Bam, like that. Okay, which if you see here, it will get wider and wider, so it will go from negative to positive infinity, because it'll get wider and wider and reach all the y values. And then my domain in inequality notation was x is all real, so since this is range, the x will turn into a y, so it'll be y is all real. So that is the domain and the range. Now last step, I did not forget like in the last video, we must make sure that our graphs are symmetrical to the line y equals x. Okay, which if you don't remember what that line is, I'm going to do the same thing that I did in the last video. So we're going to be plotting the line y equals x. Okay, if you don't know what that line is, just make a table of values and plot some points. So I'll just do 3 points this time. I'm going to do -2, 0, and +2. So if this is the equation y equals x, that means y is whatever x is. So if x is -2, y is -2. If x is 0, y is 0. And if x is 2, y is 2. So when we graph this line, if you visualize folding your paper on that line, the two graphs should be right on top of each other. It's pretty cool. Okay, so my first points are at -2, -2. And then at 0, 0, and then at 2, 2. I'm going to draw on the line y equals x, just like so. So this is the line y equals x, and if you were to kind of visualize, or if you have your own piece of paper, if you were to fold your paper on that line, the two graphs would be sitting right on top of each other. It's pretty cool. Okay, so that is the end of example 5. Now example 6 and the rest of the Prezi after this is only for honor students. It's an honors topic that we'll be covering, but if you're not in honors and you want to try it out, continue watching the Prezi video, and when you get to example 6, give it a shot.